Hello again, everyone. Today's video is all about factoring quadratic expressions. Below you see a list of many different ways that we can factor a quadratic expression. We'll go through each one of those today. I cannot express enough how important factoring a quadratic is. Once you learn it in this unit on quadratics, we will be using it for the remainder of your mathematical lives. We're going to talk about it in our next unit when we talk about polynomials. We'll use it again in the following unit when we talk about rational expressions. You use it in pre-calc. It is all over the SATs. We use it in trigonometry. It is so useful. We will use it in many different facets of our math lives. So it's best to just learn it now so that it makes learning polynomials, quadratics, rationals, all that stuff a lot simpler when we get to it. So we'll go through each one of these that you see here. So let's go through the first one, which is our greatest common factor, GCF. This is the first factoring technique that you guys have ever learned. So we're just going to review it quickly here. The steps are listed for you. If we need to factor this trinomial here, these three terms, we'd look to see first what is the greatest common factor between each term. The GCF between each term is going to be 3. Sometimes it's just a number, sometimes it's a number and a variable. This time the GCF is just plain 3. So if we take our expression up here, our original trinomial, if we take that and we divide each one of those terms by 3. So let's take a look. If we divide each one of those terms by 3, let's get all this up here. 6x plus 9. If we divide each of those terms now by 3, you're going to see that we are going to get, let's see, we divide that, and divide that term, all 3 terms, we have to divide by 3, divide by 3, we will get x squared, and then plus 2x, and then plus 3. We are just rewriting our original expression. So that means what we have left, if we were going to FOIL it or distribute, would have to come up to the exact same thing. So that GCF that we just divided by, we're now going to keep that in our expression as well. And if we wanted to double check ourselves here, if we weren't sure if we did this correctly, we could just FOIL or distribute our expression here. 3 times x squared is our 3x squared. 3 times 2x is 6x. And 3 times 3 is going to give us our 9. All right, so final answer right here. And let's go down and look at our next couple of expressions to see how do we factor those. So first one, and feel free to pause at any time if you want to try these on your own and then hit play when you're ready to check. If we're taking a look at 25k cubed plus 10x squared minus 15k, if we take a look here, our GCF is going to be a 5k. When we divide each of our terms now by 5k, I'm going to get 5k squared plus 2k minus 3. Again, if you're not sure if you did that right, you can go ahead and distribute. 5k times 5k squared is your 25k cubed. 5k times 2k is 10k squared. And 5k times negative 3 is negative 15k. If we look at our second example now, our GCF here, I see an x to the 4th, an x squared. Our last term doesn't have any variable with it, so we cannot pull that out as a GCF. The only thing we have in common is a 3 for the coefficients. So again, if I divide each of those terms by 3, I get 3 times the quantity, x to the 4th plus 4x squared, and then minus 11. And that's it. That's factoring by greatest common factor. So always make sure too for GCF that you are looking for that before you start any other type of factoring technique. Always, always, always try to look for that first. The next factoring technique we're going to go over is a trinomial with a greater than 1. So recall that a is the first term. So in this expression here, 3 is your a value. Since 3 is greater than 1, we can use the splitting the middle term technique. There are 2 techniques that I'll go over in this video for factoring trinomials with a greater than 1. First one will be splitting the middle term. So keep in mind you'll have your choice as to which method you prefer. Both methods will require you to start out by factoring your multiplying your a and your c term. So a is 3, c is negative 8. If we multiply those together, we're going to get 24. So we're looking for the factors of 24. We're looking for the ones that sum up to b, so that's 10. So we know that we're going to have different signs here because in order to get that negative 24, either the 1 or the 24, one of those 2 factors is going to have to be negative. So just keep that in mind as we're listing out the factors. So I like to list all my factors out in order. That way I don't miss anything. So 1 and 24, 2 and 12, of which I can actually stop right there because 2 and 12, if I make my 12 negative, my 12 positive and my 2 negative, I know negative 2 times positive 12 is going to give me my negative 24, and negative 2 plus 12 will give me my 10, which is exactly what I'm looking for. If I move down now to step number 2, it says to rewrite b using the factors from step 1. So I'm going to start writing out my expression, but instead of writing out 10x, I'm going to write negative 2x plus 12x, and then minus 8. So brought down my first term, brought down my last term, rewrote my middle term. I split it apart, hence the name of this approach. I split it apart, wrote it as 2 separate terms. From here, this is called factoring by grouping. We'll go over that separately later, but whenever you're looking at 4 terms, you're just going to group the first 2 and group the last 2. When I group, I don't use a parentheses. Some students like to do that. I think it gets confusing because it looks too close to your final answer. I would recommend putting a little line underneath the first 2 and the last 2 terms. From here, you're looking for the GCF. So greatest common factor between 3x squared and minus 2x is just an x. When you factor that out, you're going to be left with 3x and then minus 2. When I look for the GCF in the second set, I'm looking at a 4. And when I factor the 4 out, I get 3x and minus 2. When you're doing this factor by grouping or splitting the middle term approach, at this step, your parentheses will always be the same. If they are not the same, it's either not factorable by those methods, or you made a boo-boo somewhere. So double check first that you didn't make a mistake. And then don't force it. If it doesn't work, it doesn't work. It just might not be factorable by that method. From here, our very last step, we see that the 3x minus 2 is in common. So that is now our GCF of the expression. So I'll pull that out. What I'm left with is the x, right, from the beginning, and the positive 4. So x plus 4 is going to be my other factor. Again, step 5 was just write your final answer, but then you can also check it. If you FOIL this expression right here, you should get back to the beginning. As long as you do, you know you did it right. All right, I encourage you here, if you haven't done so yet, to pause the video, try it yourself, and see if you can get the same answers. If we're following along right now, we're looking at 2x squared plus 9x minus 18. If we are looking to factor this, we are multiplying our a and our c. 2 and 18 is going to give us 36. Again, we know we're going to have different factors because we're looking at a negative 36. So I'm looking for the factors of 36 that are going to have a difference of 9. I know if I use a positive 3 and a negative 12, right, negative 12 times positive 3 is going to give me the negative 36 that I'm looking for. And when I go to add them together, it looks like I need to switch up my signs because I need a positive 9. If I use the factors that are here, that means I would get a negative 9. So close, but not going to work for us. So let me switch up my signs. So I'm going to need to use a positive 12 and a negative 3. So splitting my middle term apart to rewrite it, 2x squared minus 3x plus 12x minus 18. Some people ask, does the order matter that you write this out here? You know, did I have to put the -3 first? Can I put the -12 first? And it makes absolutely no difference. Your next sign might look different, but your final answer will still be the same. So no, doesn't make a difference. I'm going to group my first two terms, group my last two terms, look for my greatest common factor. Same idea, look for my GCF in the next set. And 12 and 18, GCF is going to be 3. So I'm left with, actually, no, not 3. Not 3. I could totally take out bigger than 3, right? If I take out a 6, that would be my greatest common factor. Then I would be left with 2x minus 3. Again, my parentheses are the same, so that's perfect. That's going to be one of my factors. And then what I'm left with is the x plus 6, and that would be my second factor. To ensure that you did it correctly, you can go ahead and FOIL, but we did it right. I'll just let you know. Looking over at our next one, again, let's multiply our A and our C terms. So 3 times 2 is going to give us 6 factors of 6 that add up to 5. Here we have to have a positive, right? 3 times positive, 2 is positive 6. So that means either both of our signs are going to be positive or they're both going to be negative. Since we're looking to get to a positive 5, that means they're both going to be positive. So I know that here I'm going to be using a positive 3. So positive 3x and a positive 2x. Again, group my first two, group my last two, GCF, GCF. My factors match, so that'll be the first factor in my answer. And what I'm left with will be my second. Again, order doesn't matter. If you put 3x plus 2 first, then the x plus 1 second, that is totally fine. You still get the same answer when you're done. So that's factoring a trinomial with an a greater than 1 using the splitting the middle term approach, right? We do have a second approach. If you didn't like that, if that's too many steps for you, try to look at this next approach and see if you like this any better. This approach I like to call bottoms up. So you'll notice that we have the same problems on this page that we did on the last page. So that way you can really compare apples to apples as far as how many steps that it takes and if you really like this any better. So to factor using bottoms up, we're going to start out the exact same way. We're going to figure out what are the factors of A and C that sum up to B. So again, we're going to take a look and we're going to list out our factors of 24, right? We have our 1 and our 24. We know we have our 2 and our 12. Again, we're going to come to that same conclusion that to get up to positive 10, we're going to have a positive 12 and a negative 2. Step number 2, enter the factors as the second term into parentheses. Remember that the first term is always an x. So we kind of already know that our answer is going to have 2 parentheses, and each parenthesis is going to be a binomial, 2 terms. It told us in step 2 that the first term is always going to be an x. So that's easy enough. And then we'll use the terms that we had come up with from this step right here, and we'll put those into each answer. So minus 2 plus 12. Step number 3, divide the second term by the a value. If you simplify and don't get an integer, bring the bottom up. So what this means here is we're going to take our second term and we're going to divide it by our a. Again, our a value is going to be a 3. So I'm going to divide by 3 and divide by 3. Okay. 2 divided by 3 is not going to give me an integer. So that's when this approach's name comes up, and that's bring your bottom up. So here's my bottom, and I'm going to bring it up in front of my x. So this is going to leave me with an answer of 3x minus 2. In my second parenthesis, 12 divided by 3 is an integer. 12 divided by 3 is just 4. And that, my friends, is the final answer. If we double check this, right, we know from before we did this problem, 3x minus 2 and x plus 4. Same way same answer that we got from when we used the splitting the middle term approach. So some people like this method a little bit better. You can be the judge of which you'd prefer. If you want to pause and try the method again for the next sets, go right ahead. If we look at this first one, again, we're multiplying the 2 times 18. We're looking for the factors of 36 that have a difference of 9. We know we're going to draw the same conclusions of being able to use, let's see, x and x. We'll use a positive 12 and a minus 3. We're going to have to divide each of those terms by our a values, and they're divide by 2 and divide by 2. X plus, this is going to turn into a 6. But it looks like here, 3 divided by 2 is not a whole number, so I got to bring my bottom up. So this is going to make the final answer here 2x minus 3. Doing it one more time. I can set up my parentheses. I know x is in the first spot. The factors of 6 that add up to 5 are going to be 3 and 2. I'm going to divide those second terms by the a value. When I do that, I get an x plus 1, but it doesn't work out to be an integer in the second set, so I'm going to again bring that up in front and make my final answer here 3x plus 2. We can double check any of these answers by foiling or remembering too that we had just solved these exact same problems up above when we talked about factoring using splitting the middle term techniques. So you can be the judge which one you prefer. Let's talk about one more, trinomial with a equal to 1. Yes, you can use the exact same method of splitting the middle term that we just talked about, or bottoms up still works. The only condition here really is that a is equal to 1, and 1 times anything is, well, just that value. So we really kind of don't even need that step. All we have to do is look at the c. So in order to use this approach here, I am going to write a parenthesis, drawing out 2 of them, with x in the first spot. Then we're going to look for the factors of a and c that sum to b. So our factors of 42 that are going to have a difference of 1. So factors of 42, you can list them all out. When you think about it, you get 6 and 7. 6 times 7 is 42. We know we want to get to a negative 1, so that means we need a negative 7 and a positive 6. And that, my friends, is your final answer. If you want to double check it, you can definitely do so by foiling. When you do, just to encourage you to, x times x is x squared. X times negative 7 is negative 7x. 6 times x is 6x. And 6 times negative 7 is our negative 42. When we combine those outer and inner terms, or 2 like terms in the middle, we do get back to exactly where we started from. So that's our verification that we are happy campers because we did it correctly. So we can smile. Let's do it a couple more times just to practice. Keep in mind when we talked about at first, the first factoring technique was GCF, and I said always look for that first. That definitely comes into play in this first problem because each one of these 3 terms has an x in common. So let's pull out that GCF of x, of which case we'd have an x squared plus 11x plus 10. Now that is a trinomial that I can factor. I'm just going to keep my x. I'm going to keep that GCF down. Just going to bring it down into each step. I know I can put an x in the first spot because x times x is x squared. Factors of 10 that add up to 11 will be 10 and 1. We know we want positive 11, so I'm just going to make them both positives. Oops, I said 11, so I wrote it. So that's a 10, and that is a 1. And that's it. We do it again. No GCF here, so I'm just setting up my parentheses with x's in the first position. Factors of 18 with a difference of 7. 9 and 2 work for me. We want a negative 7, so it's going to be a negative 9 and a positive 2. And we're done. These usually go nice and quick. Last problem here, setting up our parentheses, x in the first spot, factors of 63 that add up to negative 16. Looks like 63 would be 9 and 7. We need the signs to both be the same. And it looks like they're both going to be a minus. So negative 9, negative 7. You need to double check if you're not sure about the signs. You can always FOIL to check. All right, so we're going to pause the video right here. This is going to be part number 1. If you choose to keep watching part number 2, we're going to talk about difference of squares and perfect square trinomials, as well as that factoring by grouping. All right, thank you so much for watching.